In this course, we'll use the Python programming language to make a password cracker. So if you never programmed Python before, I recommend that you learn the language because we'll use some things called modules and other stuff here. So it might look very cryptic if you never programmed Python before. So if you never programmed Python before, head over to python.org and download and install Python. You'll see some example code here online. But I recommend taking a course if you never programmed Python before, because this is an intermediary course that assumes you already know the basics of the Python programming language. And what we'll build in this course is several programs. One of the programs will just start entering passwords one by one until the right password is found. In another program, we have a password protected zip file. So you often find zip files on the internet, maybe in emails or other stuff. And we'll make a program to automatically crack that zip file. And we also have another project where we make a password cracker. So this is an intermediary course because you should already know the basics of Python. However, no advanced knowledge of Python is required. So you don't need to know about object-oriented programming or GUI programming or stuff like that. It's really an intermediary course in the sense that you should know the basics of Python, and that's it. First, what is ethical hacking? So you may know hacking from movies. There's a lot of movies about computer hacking. The main idea is to gain access to a certain computer or certain files that are that you're not supposed to have. For example, you may have an email account with a username password and you don't know the password, but you want to have access to that email account. It might be a remote computer, so someone else's computer where you want to get access. You may want to have certain information. So there are different ways or different types of hacking. And when talking about legal hacking, we talk about ethical hacking. So sometimes it's called white hat hacking, or in job descriptions you'll often see penetration testing as a way to show that it's legal and not criminal activity. Of course, there are different types of hacking, so you can do network hacking, website hacking, computer hacking, password hacking, email hacking, and so on. In this course, we'll just focus on password hacking using the Python programming language. And of course, this should only be used for legal purposes, so not for criminal activity. You can use this to test if your passwords are secure or if the passwords of your customer are secure. So in terminology, sometimes they talk about white hat or black hat hackers, where white hat means people who use hacking skills for legal purposes, and black hat means for criminal purposes. But in the media, that's often like totally neglected, and they'll just say hacker for everything. So if you look for kind of jobs skills, what you'll often see is that they use penetration testing as a term to totally distinguish from the criminal activity that goes on around the world. So in this course, we'll make password crackers, and it will try to automatically find a password for an account. We have 3 projects in this course that make things easier, programming projects, and you should have some Python programming language knowledge before starting this course. Now, before you get started, install a module called PyAutoGUI. You can do that with this command, and this command lets you control the mouse and keyboard with Python. So you can control the mouse and keyboard using code. This should work on Windows, Mac OS X, and Linux. I'm using Linux right here. So what you need to do is to copy the command here into your terminal and install that package. If you use an IDE like PyCharm, you can find PyAutoGUI in the module list for installing. So this works on Windows and on Linux and then Mac, and it lets you control the keyboard and the mouse using code. So download and install this module first. So copy that into the terminal and paste it for installation. Now I have already installed it, but paste that into your terminal and it will install that module. So that's PyAutoGUI. You can install it with pip. So let's build a password cracker. We have a program here, example.py, which is just for demonstration purposes. Of course, there are many graphical interfaces or command line interfaces where you can type a password. So this little program you can download as attached file, and if you run it, you'll see it will ask for a password, and it will keep doing that until the password is correct. So when you keep typing the wrong password, it just keeps asking you, and we'll try to crack the password, or to brute force it, and we'll do that by using a list of 10 million passwords. These are 10 million commonly used passwords, and the computer will try every password automatically. Now let me just show you that file. So we have a file of 10 million commonly used passwords, which people often use this kind of passwords, right? So if the password is within the 10 million commonly used passwords, then it will be guessed and the password is correct. And it will try every password one by one. So it will try this one, then that one, then that one, then that one. And we'll write a Python program to do that. So I have already did a head start. Created the program cracker.py, which opens the file for reading. So this opens the file. You can download this attached file. We open it for reading. If the file cannot be opened, so you have a try here. You get to the accept part where it says file cannot be opened. Then it will loop over every password in the password file, remove the new line character, and finally output the password. So if you run that program, you'll see it just loops over this password file and outputs every password in there. And you can break it using Ctrl+C or just wait for it to output all 10 million passwords. And we can use this password file. So the password file we have here contains those 10 million passwords, and we can use it to automatically try every password. It's called a dictionary attack. A dictionary attack, we have 10 million passwords in our dictionary. Of course, you can have different dictionaries. It can be 10 million, it can be 100 million, it can be a billion. So depending on which password list you have. So let's build a password cracker. We have a program here, example.py, which is just for demonstration purposes. Of course, there are many graphical interfaces or command line interfaces where you can type a password. So this little program you can download as attached file, and if you run it, you'll see it will ask for a password, and it will keep doing that until the password is correct. So when you keep typing the wrong password, it just keeps asking you, and we'll try to crack the password, or to brute force it, and we'll do that by using a list of 10 million passwords. These are 10 million commonly used passwords, and the computer will try every password automatically. Now let me just show you that file. So we have a file of 10 million commonly used passwords, which people often use this kind of passwords, right? So if the password is within the 10 million commonly used passwords, then it will be guessed and the password is correct. And it will try every password one by one. So it will try this one, then that one, then that one, then that one. And we'll write a Python program to do that. So I have already did a head start. Created the program cracker.py, which opens the file for reading. So this opens the file. You can download this attached file. We open it for reading. If the file cannot be opened, so you have a try here. You get to the accept part where it says file cannot be opened. Then it will loop over every password in the password file, remove the new line character, and finally output the password. So if you run that program, you'll see it just loops over this password file and outputs every password in there. And you can break it using Ctrl+C or just wait for it to output all 10 million passwords. And we can use this password file. So the password file we have here contains those 10 million passwords, and we can use it to automatically try every password. It's called a dictionary attack. A dictionary attack, we have 10 million passwords in our dictionary. Of course, you can have different dictionaries. It can be 10 million, it can be 100 million, it can be a billion. So depending on which password list you have. So we'll update the program and make it type every password automatically. So import PyAutoGUI that I mentioned earlier. We'll use that for automation of keyboard and mouse input. Then we import the time module. We make the program wait 5 seconds before it starts typing anything. Then we let it write some text and press a certain key. And of course, it needs to sleep some time. And the text we want to write is, of course, our passwords. And the key you want to press is the enter key with every password, right? Because we loop over the password with a for loop, and every time the password is typed, this is the interval between the key presses. Every time the password is typed, it presses the enter key, so it goes to the next line. And to demonstrate that, we will run this script in Notepad. So we'll open Notepad here on the side, run the program. We have 5 seconds to open Notepad. And you'll see that it starts typing every password automatically, every password in that dictionary list or password list. So it goes over every password automatically, which is exactly what we need. So we can close this and look at the code again. One thing you can do is to speed up the typing. So let's say 100th of a second. And let's clear this list. Run the program. And now you should see it start typing a lot faster. So it's trying the password at a faster speed. You can close it by clicking on the terminal, Ctrl+Z or Ctrl+C. And we can use this for our input of our other program, which was asking the password, right? Let's create a password cracker using Python. So we'll try to crack the password for this zip file. You can download this as an attached file. If I click on it, if you try to extract it, you'll see you get a password field, and if you of course it's password protected, and so by default it just shows you an error if you don't guess the right password. In order to crack the password, we use a list of 10 million passwords. So you'll see we have a huge list here. We have a huge list of 10 million often used passwords. And what the Python program will do is try every password one by one for that zip file. Now it's 10 million passwords, so commonly used passwords. So the chance is like quite a big chance that the password for the zip file is inside this list, because it's 10 million passwords that are commonly used. So how do we do that? We need to write a Python program that tries every password one by one for this zip file. So the first thing to do is, of course, to read the 10 million passwords from the text file. And you can use any text editor for creating your program. I'll call it cracker.py. You can use Vim, you can use Nano, you can use Emacs. If you use Visual Studio Code or something like that, you can use it as well. Whatever you feel comfortable with writing Python code. So I'll call it cracker.py, and we'll try to open the file. So I'll copy the file name here, because that's the file we'll try to open. So we can say our password file is open, the file name, and we want to open it for reading. Now, of course, what you want to do is to check if the file exists on your computer, because if you don't literally copy, you can have a typo in there or the file can be missing. So we want to try opening the file, and if the file cannot be opened, we want to quit the program. So this will just open the file, and it will throw an error if the file cannot be opened. Now, to test this, let's add some nonsense character here so that we know the file doesn't exist, and see that it throws an error. So we'll try cracker.py, and you'll see password file not opened, because we deliberately made a typo here. So let's remove that, try to run it again. You'll see now it runs the program without error. Then for every word in the pass file, let's output that. So for words in pass file, print words, or we could say for every password in the password file. So if you run it, you'll see it starts outputting every password in that file. And just to make things a bit more clear, let's remove the new line. So that just loops over all the passwords in the file, which is exactly what we want, right? We want to try every file in the password file. You'll see it loops very quickly over the 10 million passwords. 10 million passwords is not like a huge database, but it's large enough for to catch the most common passwords. So I have opened up Tmux because it's easier to work with it. However, for the course that doesn't really matter. So we have a zip file here, secret.zip, and the command to try to decrypt the file is unzip -p with your password, and then the zip file. So if it's the right password, it will extract the zip file into the same directory. If it's the wrong password, it won't do that. Then it will just say skipping. So we can run this command automatically with the given passwords. So let's output that. So we define the command is this command, and instead of having the word password hard-coded, we want to specify password from the file. We can delete this line. And say output the command. Then if we run the program, you should see the command, unique command for every password. And in this case, password contains a new line, so we remove that. You'll see there's a new line here every time you want the command without a new line. So we remove the new line character using the replace function, new line with nothing. So this removes the new line character from the password string or the passwords. The new line will be removed from the passwords, and then it'll output the commands each time. So if we run this program, you'll see the command for every command it needs to run, and it's just continue. You can use Ctrl+C to break it. So This is exactly what we want. And next we want Python to run this command. So we can say import OS for operating system, and then we can just run that command os.system cmd, which will run this command. So for every password in the loop, it will run this command. You'll see os.system runs the command, so it will try every password on that zip file. So if you look at the directory here, there is no, the zip file is not extracted, right? It's password protected. And now we can run the program. And you'll see now it's trying to crack the password. And if the password is in the list, it's just a matter of time before the password is cracked. So then it will appear in the same directory here. It's trying every password using that command. And of course, there will be a lot of wrong passwords because there are 10 million passwords. And depending on the password, it can take a while to find it. However, if the password is in the list, then it should work and the directory should appear in the same directory. Programmers often, or not always, but often hash passwords before they store it into a database. So when you have a database and you have like many users, what the programmer will do is store the username and the password into the database. However, a good programmer will not store the password in just as it is, like the original password, but what they'll do is store a hash. And the hash is created as input with the original password that enters a hashing algorithm and that outputs the hash. And what the programmer does is store the hashes of the passwords and not the original password. And they do that because once in a while computers get hacked or web servers get hacked, and then they would have direct access to the database and immediately have access to all of the users that are stored into the database. However, if the server gets hacked and the passwords are hashed, then the attacker only has those hashes. So what this hashing does is it takes input for text and turns that into another text called the hash or the hash sum. So with different inputs, it creates different outputs depending on the hash function or the algorithm, the hashing algorithm. If you play around with it, for example, you can say SHA256, that's a hashing algorithm, and you can type some text. This is on duckduckgo.com, and it immediately shows you the hash for that word. Now the hash is unique, and every time you change one output, you'll see a massive change in the hash. So a little change in input creates totally different hash, and the hashes are unique. So if we make a little change again, you'll see a totally different hash. Now what the web program will do, or the server, is that some app is running here that communicates with the database. The user enters the password, it goes into the hashing algorithm, and it calculates the hash that it then compares with the hash in the database. So whenever the user enters it, it goes into the hash function. You have the hash text that is then compared with the existing one. If it's the same, the user is logged in, and if it's not the same, it's an incorrect password. So programmers often store those hashes into the database instead of storing plain text. Now there are different hashing algorithms. For example, there's the SHA256 algorithm. There's the older MD5 algorithm, and they are creating different types of hashes which are of different lengths. Now the main thing to remember is just that hash functions exist, and they create an output based on the password input. So it turns the password into a different type of password, And this kind of thing is hard to reverse, right? Once you have some text like this, how do you get back to that kind of input? And the main point of the hashing algorithm is that you can't. So what a trick you can do is, like, once you have access to a web server and the database hashes, you can just go over a dictionary and try generate every possible hash from the dictionary and compare it with the database passwords. So how do you do that? Again, we have the 10 million passwords, and if we run the program, it just outputs the passwords. So we loop over the passwords. We have 10 million passwords that we loop over, and we'll use a module called hashlib to do the hashing. And for every password, we'll calculate the hash. So you can do that like this: password.encodes, and we'll say the hash or the digest hashlib dot specify the hashing algorithm you want to use. In this case, I'm using the MD5 hashing algorithm. There are different ones, so you should use the same hashing algorithm that has been used by the victim. Then we calculate the hex digits by calling the digits. So this calculates the hash, this line. And we can output that as well. So we say password and the digits or the hash. And then we can, of course, remove that line. So let's run this. And you'll see it outputs hashes. And what you want to do is also output the password. So if you run it, you'll see we have that new line again. So make sure to remove that before. Remove it using the replace function, and remove the new line character with an empty character. And now you'll see the passwords with the calculated hashes. Now you can verify that this is correct with the web browser. So if you go to DuckDuckGo.com and we say MD5 for the words sin sign, you'll see it's the same hash, 64A680. That's the same hashes here. So it's calculating the hash for every password. And if you take another one, for example, SIPI, you start with D4482. So if we calculate it, D4482, that's the correct hash for the word SIPI. And basically, if you let this program run, it will calculate 10 million hashes. And what you'll do is you'll have an input hash that you found in your database, or that you get access to that hash somehow. So the input hash. And if we run it, it will ask you the input hash. And then what you'll do is to we go over the hash word list, and if the input hash is equal to the one we found in the password list, we can say the password is found and the password is password. So that will stop the program. Sorry, there should be a break here, otherwise it won't stop. That will stop the program once the hash has been found. So when we have the password that is correct, then it will break, and it does so based on the input hash if that's equal to one of the hashes found in the 10 million hashes of the password list. So let's try that. We create the MD5 hash for some common passwords. Let's say 1234556. So there we have a hash. Let's say we found this in our database on the victim's computer. Then we can run the program, paste the hash, and you'll see it immediately found the password 123456. So let's say we found another password, another common password. Might be, let's just look it up, some common passwords. Let's say I love you. So calculate the hash for that. Let's say we found this hash in the database of the victim of the web server. So we run the program, we paste the hash, let it run, and you see it found the password is I love you based on the hash that was found on the server. So this program works. One thing you have to keep in mind is that the hashing algorithm. So like I mentioned, there's MD5, which is one of the hashing algorithms, but there are many. So the hashing algorithm turns input into the hash sum, but there are different hash functions or hash algorithms. MD5 is one of them. There's SH8256 and a lot of different hashing algorithms. So if you search for that, you can actually find a list of different hashing algorithms that exist. So these are all hashing algorithms: MD5, SEC0, 1, 2, 3. So there are different hashing algorithms, and you want to use the same hashing algorithm as the programmer has used. So once you compromise the server and you found that the programmer has hashed the passwords, you can still often find them using a program like this, where you have your password list that calculates every password the hash, and then once the input hash is equal to the hash of one of the 10 million passwords, we know the passwords. So if you have successfully created the password cracking programs and had success in finding the passwords, the next thing you could do is to look into more ethical hacking courses, or try with different kind of files that are password protected and see if your password cracking program can find those passwords. So this is just an introduction course. There's a lot more to ethical hacking. And in this course we used Python. That's optional. You can of course use any programming language or any set of tools for ethical hacking. In this case we used Python because I'm very good at Python, and at the same time it's an easy language to quickly understand as compared to the C language or C++. The Python language is almost like runnable pseudocodes, so it makes it very easy to grasp the concepts. So by the end of this course you should have all three programs and be able to write them on your own and be able to crack those passwords using the password lists.